Hello, problem solvers. Welcome back. Welcome to another lesson on Chapter 7, Subproblems. So here we've got a problem. Let's say you want an A in math. And let's say so far you have earned a total of 598 of the 700 points that have been possible. So the question is, what percentage of the remaining 225 points must you earn to raise your average to exactly a 90% to get that A? I would like you to try this problem on your own using subproblems, and then so you'll need to press pause on this video, and then when you're ready to check your answer, go ahead and press play. So go ahead and press pause now. Hey, welcome back. Let's take a look at what you did. Here are the steps I did. You might have slightly different steps, so let's see how yours compares to mine. So my first question is, what's your current percent? Like, what's your grade currently at? So to answer that question, I did 598 divided by 700 to get an 85.4. So maybe that, 90% is not unreasonable because I'm at a B right now. My next question was, how many total points will there be for this course? And I added together the 700 points that have already been possible with the remaining 225 points still left for a total of 925. Now, this question is not a good question. And that's because it doesn't really have context. Now, this is the next step that I want to do, but it doesn't really tell me what this actually means or what this is actually trying to find. So instead of writing a question like this, I should say instead, well, okay, I should actually ask what this means. And this is, 90% of 925. That is the percentage I'm shooting for, and this is a number of points. So here's the question I wrote: how many points do I need to have at the end of the class to get a 90%? And that's why I'm finding 90% of 925, and that's actually what this number means. So that's what a good question should look like. So that's how many I need at the end of the course, but I need to figure out how many more points that is to get to that. So that's basically my goal. So far I have 598, so I just subtract 598 from that number that I want, and I get 234.5. And then what percent of the remaining points do you need? And you can see basically that's what this question is. So this is my final question: what percent of the remaining points do I need? So all I need to do is get 234.5 points out of the 225 possible. Oh no. I need more than all of the points. I need more than 100% of the points, which means, this time it's not possible for me to get an A. That's too bad. Maybe this teacher gives extra credit? So there you have it. Let's take a look at another example, and I don't know. This example might make you a little sad, but we're going to talk about a March Madness bracket, which is unfortunately not happening this year. It makes me sad as well, but it's always one of my favorite sporting events, and there's a lot of awesome math we can do. Here's my question. So a lot of people fill out brackets to try to predict who's going to win every game in the entire bracket. And I want to know how long it would take to create every possible March Madness bracket. And let's say that you can make a new bracket every single second. So here we go. Now I don't want you to do this one on your own. We're going to go through this together. First question I'm going to ask is, okay, how many teams are there in the bracket? So if you know anything about the March Madness bracket, they always start with 64 teams. I'm not counting the play-in games. I'm just counting when we get to the 64 teams. Then this question might be a little challenging, but basically I want to know, okay, in the entire tournament, how many games are played? And there's a few different ways you could look at that. One way to think about that is, okay, in round 1, how many games? And then in round 2 and round 3 and so on. So in round 1, there are 32 games because it starts with 64 teams. So everyone's got to play one other team, so that's 32 games. And after that, there'll be 32 teams left. and those 32 teams play 16 games, and after that there are 16 teams left, the Sweet 16, and then there are 8 games. After that there are 8 teams left, the Elite 8 play 4 games. There are 4 teams left, that's the Final 4, and then there are 2 games in that round, and then finally there's the championship game for a total of 63 games. Another way to think about that is there are 64 teams at the beginning. Every game eliminates 1 team. So you need to play 63 games to eliminate 63 of the 64 teams, leaving 1 champion in the end. Now this next question is, how many brackets are possible? This one's a little tough. Basically the idea here is every time there's a game, you have a decision to make, and there are 2 possible decisions. Either, Team A wins or Team B wins, and you need to do that 63 times. This team or that team, 63 times in a row. And you have to get all, you can make a different choice for each game. So to count that, you actually do 2 to the 63rd power, which is this really, really big number. It's so big, in fact, that your calculator can't even display it all. I had to use the internet to look up what this value was. But if you think about how big this number is, this is a ridiculously big number. These are thousands, millions, billions, trillions, quadrillions, quintillions. There's over 9.2 quintillion possible brackets that can be made. Okay, that's so many. All right. Now the question is, could you make all 9.2 quintillion of those if you could complete a new bracket every second? Well, basically, it would take you this many seconds, 9.2 quintillion seconds. But I want to put that into something that's a little more understandable. So I take that number and I convert it to minutes by dividing it by 60. I'm not going to write that answer down because it's another really big number. But then to convert that to hours, I divide that by 60 because there are 60 minutes in an hour. I'm then going to convert that to days by dividing that by 24 because there are 24 hours in a day. And then finally, let's change that to years. And I'm just going to assume all the years have 365 days, so I'm going to ignore leap years. And it will only take me, oh boy, thousands, millions, billions, 292 billion years to create every possible bracket if all I do every second of every day for those 292 billion years is make 1 bracket a second. I never sleep, I never eat. Every second I just create a new bracket. Now this is why nobody has ever gotten a perfect bracket when trying to predict an NCAA tournament, because this number is so big. There are so many different possible arrangements. And it would take you 292 billion years to create them all. I've got a follow-up question to this, though, and that is, what if instead of you working on it alone, you got everyone on planet Earth to help you, and everyone on planet Earth could also make 1 bracket a second? And somehow you coordinated all your efforts so that no one ever made the same bracket that anyone else made. Everyone was always making new brackets. Well then, next question I would ask is, how many people are on Earth? I looked it up and it's about 7.7 billion is the approximate, at least as of 2019. So then, all I need to do is say, okay, so how long would it take if everyone was working on it? Well, I take that total number of years that, it would take 1 person, and I divide it by that 7.7 billion, and it would only take about 38 years. So if everyone on planet Earth started making brackets right now, and everyone could make a new one every second, it would take 38 years for us to make all possible brackets. And by that time, the tournament is over, has been over for a very long time. And there have been 37 other tournaments that have occurred, which that doesn't really work. But that's why no one's ever filled out a perfect bracket, is because it's such, there are so many possible brackets. Here's your homework. Use subproblems, list your questions, then answer the question. And please email me if you have any questions.